A module for cybersecurity that is banking focused is really required. When we look at this, there are a few modules that I'll actually go through. There are the cyber kill chain. This is where we actually look at the 7-step that's usually used by hackers or people that are trying to breach your environment. There are 7 steps that they are trying to do. That is the actual attack chain. And we'll go through each one of those steps and also the 6 options that you can actually have as from a broader point of view to actually combat that cyber kill chain. And also an approach in the banking sector. This is specifically where you need to really look at your security design. This is why I discuss zero trust, and many organizations and vendors have come up with a zero trust factor. And here I look at 6 pillars where you have to approach and create a new environment that's trusted. Use this part of your digital transformation or digital banking first. We'll then go through a post-mortem of a banking breach. And here we actually look at an example, a real-world example where we've changed the data so that we can't indicate what the bank was. But here we see that the hack was done from the outside. Somebody clicked on the inside. They created a reverse tunnel to the outside. And this bank was compromised for more than 200 days, whereby some SWIFT, mobile banking, and also internet banking frauds were taking place from the external as if they were hands-on keyboard inside. Quickly touch on cybersecurity frameworks and the metrics around that. So the cybersecurity frameworks specifically look at NIST cybersecurity framework. There's a version 1.1 at the moment, time of the recording. And then also what you can actually look at metrics. And this is your risk appetite document and the things that you can actually look at when you feed back to a reporting environment. The dashboards and real-time monitoring, some stuff that are available from a commercial point of view we actually will touch on. Also from your implementation, if you're using different operating systems, what is available in the cloud environment and also on premises. Real-time monitoring and how you can actually do that using some open source software. At the end of the day, it is best to actually get something up and running as soon as possible, get the indications without going through a whole process where you actually have to do a proof of concept and so on. You can do that at a later stage. Then we'll actually then a little bit deep dive into zero trust pillars and your production systems, how you can actually look at your payment gateways, your production systems, and how zero trust fits into this. We'll actually look at also using equipment and operating systems and applications that you already have without spending any money, because you have to apply the inherent security initially before going out and actually trying to apply a plaster on a large wound. Then also we have implementation suggestions of looking at things like your network environment, your application, and also the authentication and access environment using the operating systems and different authentication schemes. And then finally, we'll actually look at a next level of the session content where we drive a little bit more on the technical side. So once you're actually happy with this and you want to look further, otherwise level 200 can be a standalone module or course by itself as well. We need to consider the cyber kill chain and any defensive actions that we can do within our organization. This is a very quick introduction about the Lockheed Martin cyber kill chain process. Now, computer scientists at Lockheed Martin Corporation described a new intrusion kill chain framework or model to defend the computer networks in 2011. They wrote that the attacks may occur in phases and can be disrupted through controls established at each phase. Since then, the cyber kill chain has been adopted by data security organizations to define phases of this cyber attack. The cyber kill chain reveals the phases of a cyber attack, from an early reconnaissance to the goal of data exfiltration. The kill chain can be also used as a management tool to help continuously improve the network defense. According to Lockheed Martin, threats must progress through several phases in the model, and these include the following. We have got the first step as the reconnaissance. We have weaponization. Then we have to deliver that weapon. Once the exploitation takes place, we do the installation, or the attacker does the installation, then that installation would connect back to a command and control center, and then the final step will be the exfiltration. Now, quickly to review each one of these processes is that your reconnaissance is the research, the identification, and the selection of targets using numerous tools, including open source intelligence gathering and applications of us end, but also on the dark web. A lot of information is available for targets. Step 2, the weaponization is the development of a remote access malware weapon, such as a worm or a virus, with specific actionable attributes. And sometimes this development is targeted specifically for an organization. We've seen that malware is developed with the IP address of certain servers within the organization once they've actually identified those. The delivery step is the attacker then transmits that weapon that was developed to the intended target. Numerous methods, including email, websites that you visit that has been compromised, US devices, applications such as demos or games or anything like that, tools that are downloaded such as hacking and cracking tools sometimes by staff, contains these weapons within the delivery mechanism. But then once the delivery has taken place, the exploitation is the next step. So this malware weapons program code triggers, which takes action on the target network to exploit a certain vulnerability. That could be an unpatched vulnerability or even a zero-day vulnerability. Once that is done, the malware would install access points. It will create backdoors, and that will be usable by the intruder. Mostly, the next step is the command and control. This is where the malware enables an intruder to have hands on the keyboard, persistent access to the target network. This is the virus or the malware or the weapon from an internal point of view connecting back to a predetermined target, whereby a hacker would sit at that target and actually have a reverse tunnel in the organization. A firewall normally does not help in that situation. And finally, the step 7 has been identified as exfiltration. This is where the intruder takes action to achieve their goals. It could be anything from data exfiltration, data destruction, or encryption for ransomware. Now, what we need to do is actually look at the defense's course of action within this cyber kill chain. We have 6 steps that we can do. We can detect, we can deny, we can disrupt, also degrade, deceive, and contain. Each one of those steps, if we look at it, detect would be, for example, the monitoring and logging to a SIM or a security incident and event management in order to determine unauthorized access. Next, we'll deny, where we can prevent information disclosure and unauthorized access with role-based access control. The next step 2 is to disrupt, to stop or change outbound traffic to the attacker using tools like firewalls or edge routers, and then we can degrade the communication. So this is a counterattack command and control or internal attacks. So once we've identified that we actually have an active attack taking place, there's many things we can actually do. For example, cut the communication to the identified IP addresses in the back end, or we can contain the system to identify what was stolen and make a forensic image of that system. We can also deceive, meaning we can interfere with the command and control with tools and techniques. These also include things like honeypots. Honeypots in your organization could be systems that pretend to be production systems, but what they do, they deceive the attackers to actually try and attack them, and you can actually log them. So if you have a honeypot and somebody actually attacks us, you know that you have a high possibility of a breach in your organization. And finally, we need to contain this attack, whereby we can do network segmentation changes and also microsegmentation. This means that your production, for example, is totally segmented, and within the production environment you might have your SWIFT or your Forex payment system totally segmented. Nobody can get to that. You might have your multi-channel payment system on the other side, and every one of those channels are segmented and separated from each other. The advantage of this as well, if you have that microsegmentation, any transgression between those segments can be identified and logged to your SIM. Cybersecurity, a modern approach in the banking sector. We actually see that we have a lot of problems. We've been spending a lot of money, we've been buying products, and what we see in the world is that many of the other banks are getting compromised, and we're actually sitting back and saying, are we doing the right thing? Are we doing the right thing at the right time? Are we spending enough resources? Are we spending enough money? Or if the money we spend, is that actually correct in this scenario? So what we need to do is actually relook and possibly looking at a new approach of doing cybersecurity in our banking industry. Now, we have seen an increase in the number of security tools and solutions available to mitigate these security threats. We see often somebody coming and saying, this is a silver bullet. This is using artificial intelligence or machine learning, and we can actually solve all your problems. Irrespective of that, what we've seen is an increase of the number of breaches in the financial sector. So what we'll do, there's multiple modules, and in this module, I will discuss a bank that have been compromised numerous times and what we can learn from this and how we can approach this. There is an approach. It's called Zero Trust. You should have heard this within the market, and everybody's sort of like talking about that. This is covered, and it shows that security needs to be addressed holistically and that there are no silver bullets available. We need to do it properly and taking a approach that everything is not negotiable. I'll look at some of the attack vectors used by the Advanced Persistent Threat, or otherwise known as APT actors, which is usually a state-sponsored hacker. Now, when we look at the 5 pillars of an IT platform architecture, there are things like cost optimization to maximize the value of any delivered solution. We're also looking at operation excellence, where we make sure that things are up and running and making sure production is up and it's actually up to date and it can serve our clients. It's a performance efficiency where elasticity or the ability to respond to changes in the load of the system is handled adequately. Then reliability, where this is the ability of a system to recover from failures and to function as designed. The final point, which is our focus here, is security, which means protection of applications, users, and data from all those threats. Now, the Advanced Persistent Threat actors, or the state actors, target specific industries and regions. One of the examples I'm using here is a bank in Chile. Now, there's also the Banco Estado, that is the state bank. So in Chile, that's the only real public bank that they've got available. Although what we've seen is numerous compromises. We've seen actually 3 compromises that's been publicly announced, anyway from a hack from a payment system gateway up to ransomware. And also at the end of the day, we've seen some Chilean ATM attacks. Now, this is between 2008 up to 2020 in September the 5th. Now, if you actually look at that, we're actually looking at 12 years between those with numerous attacks that's publicly known. And we don't know what other unpublished vectors have been internally as well. So we need to understand they have been identified, they have been notified, possibly internally they've taken some action around that, but why does it still happen at the end of the day? This is where we are now. So as a bank, we need to actually step back and say, listen, what do we need to do about that? So if I want to look at Banco Estado quickly, we actually see that they actually have had a swift hack losing $10 million. Initially, they said, oh, no, it's a virus that came in, nothing serious, and so on. And a couple of days later, a week later, it came out that it was actually a compromise using a phishing attempt. Then also there was a ransomware compromise by Revil. There was an ATM hack. And as you can see, it's a 12-year journey. And it seems like not centering out Banco Estado here, but it is all to do with, are we learning lessons from that? Are we really taking action? Don't we need to take a step back and make sure that this is actually done properly? Now, if I actually look at this, now we've done a couple of reviews, a couple of compromise recoveries, and what we find is that information security and internal audit or risk management is run by numbers. This is all to do to make sure that management, senior management, are happy that the risks are mitigated. An example I'll give you here, and this is purely an example. We'll sit in a meeting and we actually give feedback to the executive committee, and we say that 99% of the workstations are protected adequately by the antivirus software. Of those 99%, we actually see that 95% of them, the antivirus software is up to date within the last 7 days. Now, what we've seen as well, some organizations use some days to look at. If it's 7 days update of the signatures, they're happy. If it's 14 or 28 days, we start getting, we have got some values to reach. And often what happens, because this is done by people, these security reports are usually in a green status based on the risk appetite and to give a comfort level back to the management. Now, the problem here is that 1% of the workstations that's not having antivirus software is an attack vector in your bank. That 5% of antivirus software that is not up to date, that may miss a 0-day or actually a new malware strain that is an attack vector in your bank. And sometimes we find some of the analysis is that some of those viruses are developed specifically for you. As a bank, they actually target you because they actually got a foothold in your organization. So it is not a virus in the wild, but it is developed purely for you. So what do we need to do? There's a fresh approach that we need to do. First and foremost, all devices and users must be authenticated and trusted. This is a non-negotiable. So every user logging into your system, every user that's defined in your system, they have to be identified and authenticated and make sure that they are a real person and they actually can come back to your, what we call a gold user list. Access must be based on least privilege. Second rule here. So every user that has got access, they have only access to what their job role specifies. This could be a user with an application, and at the top level, it could be an administrator that actually needs access. And we'll look at that later in the other modules, how we actually handle that specifically, because this is really important. Finally, quite a different approach to actually, we have to assume a breach. Usually when we get into an organization, we need to say, we don't trust this environment because there could be other things that are not detected. The average compromise is more than 250 days before it's detected. So we need to understand that we don't trust the environment and we have to start locating, securing different segments and actually move or migrate untrusted environments, vet them and move them into a trusted environment. Now this is where we come to zero trust security. Very quickly around here, zero trust has been coined in 1994 actually, and then a lot of vendors came to the party and says this is how we handle zero trust. First and foremost, let's look at identity. Every user is identified and trusted. Then the next point is endpoints. This is all my devices. How do I log onto the network? What computer do I use? Laptop, bring your own device. Every device connecting to your bank's organization and network must be identified and trusted. And often that trust is only for a certain point because that trust can be lost during a certain time. Then also data. Data is, of course, the new monetary value in organizations because data can be sold. Data has got value. So data should be classified and protected according to your data classification policy. Then the next step is applications. Now, applications we know it runs within the organization. Within a banking, we've got many applications. We've got the core banking solution, and the core banking solution has got a database that talks in the back end, which is called the customer file system, which is really important, and everything works around that. So the core banking application should be vetted, and every person or identity, as we have identified before, every identity and endpoint needs to be vetted that they communicate securely to the application. So there should be a two-way trust between those. Also, when we look at applications which meet the high security requirements, producing user information, doing transactions, they should be verified and trusted. And when we actually go to the DevOps or DevSecOps, we need to develop low and deploy high to make sure that they are trusted. Infrastructure, really important because we're running everything. We're operating systems. We can actually do cloud. We can do a hybrid environment. That should be monitored and managed. And this is where we make sure we don't have any shadow IT. Finally, one of the last pillars here is traffic. Traffic should be protected in transit, monitored, and also microsegmented. Microsegmentation is really important when we look at this zero trust environment, where we could have a environment that deploys an application, for example, internet banking or mobile banking, and it's totally segmented, and any access in and out is monitored and authenticated based on identity and endpoints. Now, delving a little bit deeper on each one of these components, we're looking at identity. Every user must be identified and have access only based on the role that they do have. Privileged users, this is administrators that actually look after the system. They do changes on the production systems. It could be database administrators. They must be controlled and have access only when it's required, and should have an anniversary date. Anniversary date means that they are reviewed and make sure that they are still current, and it could be a self-assessment. There's a lot of processes we'll discuss later in some of the modules later. Also, any administrative access in your environment should be done from what they call a privileged access workstation or a POR. This could be a jump box that's highly secured, which means that no administration can take place from a user's desktop sitting somewhere. It has to be vetted. The next item, if you look at, is endpoints. Endpoints are really important, which means that those are the places where people work at or applications run on. We need to control all workstations, all servers, mobile devices, point of sale systems. We're seeing Internet of Things coming up. We need to look at that. We have got the ATM or the automated teller machines. Those need to be controlled as an endpoint by ensuring it is identified and trusted. The next item we look at is data. Now, data is very important. As I said, it actually does contain some value to be sold by on the black market, so this is where if somebody compromises or breaches your environment, this is where they'll go for first. Data. Now, data should be classified according to your data classification policy. Data should be secured according to the classification that it is allowed, and hopefully we actually have automated issues around this. So this is part of data leak protection or DLP. So the access to data should be based on least privilege. Also, data at rest should be protected, data in transit should be protected, and this is where we're looking at certain things like encryption. Is it based on the operating system? Is it based on the devices? Or is it based on point-to-point? So these, at a later module, we look at that from a technical point of view. Also, data ownership should be clear, which means that if the database has been defined or any resource has been defined, it has an owner which is responsible for this to make those decisions within your organizations. Applications, applications can act as subjects and must be identified, verified, and trusted. Now, a subject is like a user. So an application can act as a user, meaning it can log on, it can do all these things and actually need to be vetted and verified. Applications can be used as an attack vector, and whitelisting is a control. When we discuss later within the level 200, we'll actually look at whitelisting as an option and how you can do with it within your environment. When we look at attack vectors earlier, we actually can bring up words like solar winds, for example. These are supply chains that's been compromised to actually compromise many organizations. If we look at on-premises, we look at the Exchange service, for example, OWA or Outlook for web access or applications. Those were also compromised because they were never updated according to based on the cloud environment. Also, mutual trust is really beneficial between a subject or the user and an object, the application, and that must exist before any access is granted. And the beauty of this is once you actually have identified that, you can actually create the triggers to log those events in your environment. Finally, within the infrastructure environment, or penultimately rather in your infrastructure environment, we need to look at things like the operating systems. These could be on-premise, the operating system, your network operating systems, your virtual environments, and then also finally, if you actually decide to go to a cloud environment, we've got a cloud adoption and migration policy we need to go to. But very important here is before we go to a cloud environment, we can only migrate verified and trusted infrastructure. What does that mean? Well, very simply, if you've actually got an on-premise environment and all your users are defined, but you cannot trust your local directory environment, could it be Active Directory, it could be any other accounting and authentication environment. If that is not trusted and you move that or migrate that to a cloud environment, you do have a problem because then you cannot trust your cloud environment. And then finally, we can also have a hybrid cloud environment, which means that as a bank, we can have our data center where I've got applications running, do the crunching. I can't put some of the data into the cloud because it might be regulated by legislation locally, and then move those things that could be moved into a cloud environment, push that so we actually have automated discovery, backups, and threat detection in a cloud environment, because that's quite good. And then finally, we come to a network environment. Now, a network environment, this is important because all communication between all objects and subjects need to be verified between point to point. Encryption should be based on best practices such as FIPS or FIPS 140-2. All traffic should be inspected using network monitoring. Then also we look at intrusion detection services and intrusion prevention services. Those should be based on the associated risk within the environment. And then also, although it's not noted here, there are things like if you start publishing your applications within the web environment, you have to have denial of service protection at your endpoints. Now, actually, what is the next step? We need to decide. So once we actually look at those 6 pillars, those are very important. We need to actually look at what can we do around that? What can we actually take to the next step and discuss with my staff and my environment and my security, what should we do about that? First and foremost, we are going to create a roadmap in the next modules. And this roadmap can be adopted based on what we actually discuss here and applied and actually put this framework around your elected environment. So first and foremost, we're going to select a framework to address cyber risk. And then what we'll do as well is to take that framework as an example and align that with elective and non-negotiable legislative requirements. This could be, for example, PCI DSS. So there's a payment card industry requirements and how we feed that back into our framework and using dashboards to monitor that. There could be also ISO 27000 series. For example, here the 27002 that gives us the basis of the information security management services. We have got COBIT as an example, and there's many other frameworks that we can actually apply that, and we will do that around that and feed that back into the initial framework that we've selected. Now, which one will I select? So I'm going to do In the next module, I'm going to do and select the NIST, which is the National Institute for Security and Technology. So it's for standards and technology. We're looking at the CSF, or the Cybersecurity Framework, and align that with elected and legal requirements. Then in the next step, what we'll do as well is identify those and create metrics for executive level and board reporting. So this is actually quite exciting. So we will take what is available in the market, apply it in an environment, making sure we don't spend any more money than we should do. We will look at inherent security requirements, apply the inherent what we've already got, making sure that that is adequate, making sure that metrics are around that, and then we'll take the next step and see if we have to really get something else on the line. Rather use what you've got, which you haven't deployed yet, and actually make sure that your risks are mitigated. Cybersecurity frameworks is fairly critical to actually select one and make sure it's not too complex, and actually use that one to actually create a blueprint what you need to do in your organization and use that as a metric system. Now, one of the frameworks I will discuss here, a cybersecurity framework, is from NIST, or the National Institute for Standards and Technology. It is called the NIST Cybersecurity Framework, CSF, and currently in the version 1.1. It has 5 functions, and those functions are to identify. This is all about asset management, business environment. So we actually have to document the business flow and where we actually have critical businesses. Also from a governance point of view, where there's legal and other frameworks around that, but we actually have to ensure that we abide by something. For example, a governance environment or governance enforcement within the bank would be PCI DSS, or the payment card industry standard. Then also within, after we've identified all the objects, we can do a risk assessment and then have a risk management strategy. In order to protect all our data after we've identified there, we need to have access control. We have discussed that earlier in a zero trust, where we look at identity and have role-based access control. Awareness and training is very important. As we increase the awareness of the people, the incidents will normally increase because they're aware of what's going on around them, and then taper down. Also, to protect is data security. We mentioned earlier the confidentiality policy, the access to information, and also electronic communication policies that we actually have to have. Infra protection, such as procedures and processes, maintenance of all our systems, and then also have protective technology. This is certain like firewalls, antivirus, etc., to make sure that we protect all our assets that have been identified. A very important fact here as well is that we have to detect. So this means that there has to be a continuous security monitoring, and all anomalies and events has to be logged for forensic investigations and for detection purposes. Now, once we've detected a breach, for example, we have to respond to that. Part of the planning processes, communication between different departments in a sense of a breach is really important. After the actual response has been done, we do a needs analysis and a lessons learned, make sure that the risks are mitigated, and after the lessons learned, we have to do the improvements. What do we change? What can be done differently? And finally, we have to have a look at disaster recovery, for example. We have to have DRP and BCP, disaster recovery planning and business continuity. And once we actually look at all these programs, we have our tests, we have our plans, and then we can actually also see where the improvements can take place. And communication, again, once is very important. Yeah. Now, when we actually look at the cybersecurity framework, as I said, there are 5 different functions here: identify, protect, detect, respond, and recover. And each one of these, when we look at it, for example, identification. So if we look at identity, is where we develop the organizational understanding to manage cybersecurity risks to system, assets, data, and capabilities. The activities in the identify function are foundational for effective use of the framework. Understanding the business context, the resource that is support critical functions, and the related cybersecurity risks, which enables an organization to focus and prioritize its efforts consistent with its risk management strategy and business needs. Example of outcome categories within this function include asset management, business environment, governance, risk assessment, and risk management strategy. If we don't do the asset management identification function adequately, everything else falls flat. When we look at protect, this is where we develop and implement the appropriate safeguards to ensure that the delivery of critical infrastructure services. The protect function supports the ability to limit or contain the impact of potential cybersecurity event. Examples of outcome include categories within this function include access control, awareness and training, data security, information protection processes and procedures, maintenance and protective technology. The detection side, when we develop and implement the appropriate activities to identify the occurrence of a cybersecurity event. The detect function enables timely discovery of cybersecurity events. Examples of outcome categories within this function include anomalies in events, security, continuous monitoring, and detection processes. Then we have to look at response to develop and implement the appropriate activities to take action regarding a detected cybersecurity event. This respond function supports the ability to contain the impact of potential cybersecurity events. Examples of outcomes categories within this function include response planning, communication analysis, mitigation, and also improvements. Then finally, the recover function is where we develop and implement the appropriate activities to maintain plans for resilience and to restore any capabilities or services that were impaired due to a cybersecurity event. The recover function supports a timely recovery to normal operations to reduce the impact from a cybersecurity event. Examples of the outcome categories within this function include recovery planning, improvements, and communications. Now, we do all this from an asset risk management point of view based on a document called the risk appetite. Here I have an example where, for example, I have a risk requirement, the appetite that we have, the metric that we'll use, and also the red, green, and amber rating of that actual attribute. For example, number 1 here is a physical device and systems within the organizations are inventoried. The problem we have here is we don't identify any device in our environment that is part of a crucial path, for example, a network device, a router, a switch, or a point of sale, or any type of encryption, and also IoT, of Internet of Things. If this is not inventoried, we have a problem whereby it may introduce a risk and no risk in the environment. So if we look at the appetite of that physical devices, the number of known devices at the head office and at the branches, the devices should be logged into a central CMDB or configuration management database. The number of new devices within the first and last date seen as an attribute that is used. If a device has not been seen in the last 30 days, it should be noted as no longer active in the domain. If it does become active after being disabled, a trigger needs to be sent to a hardware inventory scan done within an hour. So this is, for example, one of the appetites that we're allowed to have for physical devices in the network. So if we actually see that there are devices that are not inventoried, for example, within an audit or actually part of the scan, and we see devices but they're not in the CMDB and they're greater than 5%, this is a high percentage. And also very important is to adapt a certain policy review and look at another framework. For example, here I am using the ISO 27000K adaptation to a policy. And as you can see here, the example I'm using here, I may have many requirements on the left-hand side in the first column. If we look at, for example, a risk management, we need to do risk assessment and also have a security framework and strategy. If you see COBIT defines certain attributes that has to be enabled, ISO 27000 has a certain attribute. We can look at ITIL, and we can look at other standards as well where those attributes need to be identified. Once we've done that, we actually would have policies, standards, procedures, and guidelines, and each one of those documents should make sure that it covers any of those attributes to make sure that all our policies are aligned with the frameworks. And also, what you need to develop after the NIST cybersecurity framework is to look at some technical steps. For example, if you want to do an hardware inventory, here we've got a program developed that you can actually, for say, step 1, to deploy an automated asset inventory discovery tool, and that will log into a configuration management database. But this is a whole process where everything is properly documented step by step, or the procedures, so that you must make sure that the business runs adequately. You can use these attributes or these steps to make sure that you are in line and measured according to your risk appetite. Then also what you need to do as part of the first phase of the cybersecurity framework is to identify all the phases. All those data elements should be identified and classified according to the information classification policy and controls applied. So you see, everything starts working together in this. We also have people, processes, and technologies where it is an effective governance, which is an ongoing effort. There's also policies, guidelines, and standards in the first column, and we need to understand where the data ownership is there. Also, the data quality framework, what work is produced, how we actually do quality assurance, and that is data stewardship. Then we actually have privacy, compliance, and security in your organization, where we have role definition and accessibility to those components or those data elements. We have information architecture and integrations within the business, where we identify a reliable flow of information, so we can understand where the data starts, where the data ends, and if it is a trusted path. Then also reporting and analytics, knowledge from that information. So if you put all these together, it means that we actually have data-driven decisions and measurable outcomes. And this is where we'll look later at the actual metrics and how we can present this to the board at the end of the day, looking at our current security stance and how it is improving or not. I think also once we've done this, we need to take a step back and say, what is our Chief Information Security Officer doing? Has he got a good handle on everything? What is the reporting we do get out here as well? Sometimes also, like I said, reboot, refresh, take a step back and actually look at what is your cybersecurity framework. What are you actually using around that? What anomalies do you have? Where do we have automation where feasible? And also, do we have already all the metrics and dashboards which we actually give to management, which is executive management, and also the board? These should be in real time. We have a program available where we actually look at the first 101 days, where we actually break it down into 30 days at a time and looking at each category of work, the current status one has to be done. So after the first 90 days has been completed, that will actually have a framework in place where we actually have the next 11 days going through the process where we automate these things, and that every effort that you have done for a security solution architecture is automated and only done once, and this is reported automatically.